K-means clustering is an unsupervised machine learning algorithm which partitions n instances into K clusters by computing similarity. Hi everyone, I am Bindeshwar from Post Network, and in this video I am going to explain K-means clustering algorithm. So let's get started. K-means clustering is an unsupervised learning algorithm. So training instances will not have tables. And to understand K-means clustering, I will take a very simple data set having 3 features without labels. So I am writing here. The first feature is x1, having values 12, 16, 14, 18 and 12, and another feature x2 having values 40, 35, 37, 36, 40, and the third and last feature I will take values here 30, 29, 25, 21 and 31, and you can see that there are 5 instances. So I am also sequencing them 1, 2, 3, 4 and 5. So see that the basic idea behind K-means clustering is that partitions these instances into number of clusters. So suppose that if I want to partition these instances into 2 clusters, namely cluster 0 and cluster 1. So how will you partition? First of all, you have to choose 2 centers. Here you will say centroid. So just make a circle, and first of all, for a cluster 0, I am taking first instance as cluster, and for a cluster 1, I will take second instance as centroid. Now you have taken 2 instances, first and 2. What about 3, 4 and 5? Which clusters they will fall? So now let us see that in which cluster 3 will go. So basically you will start from calculating Euclidean distance. So you will calculate Euclidean distance from instance number 1 and instance number 2, basically from centers. So calculate D1, 3. That means that distance between 1 to 3. So you will calculate here Euclidean distance. So here Euclidean distance would be 12 minus 14 to the whole square plus 40 minus 37 whole square plus 30 minus 25 whole square, and that would be equal to 2 square plus 3 square plus 5 square, and finally that would be equal to under root 38. Now let us calculate distance from 2 to 3, because you want to decide that whether instance number 3 will go in cluster number 0 or in cluster number 1. So you are computing the distance. So if your instance number 3 is closer to 1, it will go in cluster number 1. If it is closer to 2, it will go in cluster number 2, not cluster number 2. Actually, I have named it cluster number 0 and cluster number 1. So if it is closer to center 1, centroid 1, it will go in cluster 0. If it is closer to centroid 2, so it will go in cluster 1. Now let us compute distance from instance number 2 to 3, where instance number 2 is centroid. Now see that if you calculate, that would be equal to 16 minus 14 whole square plus 35 minus 37 whole square plus 29 minus 25 whole square is equal to, that would be equal to 2 square plus 2 square plus 4 square. That would be equal to under root 24. So in this case you can see that D 23 is less than D 13. That means that instance number 3 is closer to D 23. So instance number 3 will be part of cluster number 1. So here it would not be part of cluster number 0. And one more thing you need to see, that when a new instance goes in a cluster, so new centroid will get calculated, and it would be average of or midpoint of instance number 2 and 3 in this case. So I'm going to write it like C23 means midpoint of 2 and 3. So you will calculate midpoint like 16 plus 1 4. These are x1 features, x1 values. Thereafter 35 plus 37, not minus, upon 2, thereafter 29 plus 25, 29 plus 25 upon 2, and the new center would be 15 comma 36 and 27. See that what will happen if you compute another distance from centroid. So you will calculate from this centroid. Now let us see it by example. Suppose here 4. Now 3 with cluster is decided for a 3. Now how will you decide cluster for 4 instance? So again you will compute distance from, in cluster number 0, I am writing here C0, not C0, I am writing cluster 0, and here cluster 1. So in cluster 1, cluster 0, not cluster 1, in cluster 0 there is again only one instance. So centroid is remain instance number 1. So you will calculate distance from D1 to 4, not 4 to 1, 4 to 1 or 1 to 4, that is equal. Now see that you will calculate this distance, and see that how will you calculate. You will use again Euclidean distance and under root 12 minus 18 whole square plus 40 minus 36 whole square plus 30 minus 21 whole square, and that would be equal to under root 133. Now again calculate the distance from 2, 3 here. I am writing 2, 3 because you are calculating distance from average of midpoint of 2, 3 from 4. That's why I told you that you will calculate distance of 4 from new centroid in cluster number 1 with respect to cluster number 1. So let us see that what is the value. So it would be 15 minus 18 whole square plus 36 minus 36 whole square plus 27 minus 21 whole square, and that would be equal to finally under root 45. Now again see that D to 3 to 4 distance is less than D 1 to 4. That means that instance number 4 will belong to cluster number 1. I am again writing here. This is 1 and cluster number, this is cluster number 0. Here 2, 3 and 4. Here you can write like this one. New centroid would be calculated cluster number 1. So 4 will also go in cluster number 1. In cluster number 0, still there is only one instance, which is instance number 1 and which is also centroid. Now you will calculate centroid of cluster number 1. Cluster number 0 has still instance number 1 is centroid. So how will you calculate centroid of cluster number 1? C 2, 3, 4. So you will calculate like this one. 16 plus 14 plus 18 upon 3, comma 35 plus 37 plus 36 upon 3, comma 29 plus 25 plus 21 upon 3, and finally that would be equal to 16, 36 and 25. So actually that would be somewhere here, center of 2, 3 and 4. That is centroid. Now let us see about instance number 5. So to see that where instance number 5 belong to, calculate D1 to 5, which would be equal to, write in square root 12 minus 12 whole square plus 40 minus 40 whole square plus 30 minus 31 whole square, and that would be equal to 0 whole square plus 0 whole square plus 1 whole square. That is under root 1 and it would be equal to 1. Again D 2, 3, 4 to 5. I am writing here actually this is centroid 2, 3, 4. Average of these 3, or you can the midpoint of 2, 3, 4 to instance number 5. Now let us calculate it. So 16 minus 12 whole square, 36 minus 40 whole square plus 25 minus 31 whole square, that would be equal to 4 square plus 4 square plus 6 square, that would be equal to under root 68. Now in this case you can see that 1d1 to 5 is less than d2 3 4 to 5. It means that instance number 5 will belong to cluster 0. So again what will we do? We will calculate centroid of cluster number 0, because when an instance goes in a cluster, new centroid will be calculated for that cluster. So I am writing C 1 5. Actually I should write C0 here, 0C here, 1C means cluster number 1, and midpoint or average point of 2 3 4 here for cluster 0, midpoint of 1 5. So let us see that. We will calculate like 12 plus 12 upon 2, 40 plus 40 upon 2, comma 30 plus 31 upon 2, and that would be equal to 12, comma 40 and 30.5. So that would be the centroid for cluster number 0. And final centroid for cluster number 0 is 12, 40, 30.5. And centroid for cluster number 1 is 16, 36 and 25. And point number 1, which I have already taken as cluster center or centroid, and 1 and 5 will be in one cluster, 2, 3 and 4 would be in another cluster. If you have taken to decide to partition into 2 clusters. Now see the Python code here. If you see the first line, I am writing also from sklearn cluster. So library is sklearn, and again there is sub part of library or sub library, you can say that library is divided. So there is a cluster, another library into library, and K means is class. Now an instance is created, KMC, K means clustering, in which we have provided number of clusters, and only we have taken data having independent features, or you can say that x1, x2, x3. There is no labeled data, that's why there is not any y variable. Thereafter machine will get trained, model will get trained, and here KMC dot labels, so it will print labels. So you can see that here this output would be from KMC dot labels. So that means that instance number first and last, that would be in cluster number 1, instance number 2, 3 and 4, that would be in cluster number 1, and 1 and 5th, that would be in cluster number 0, 2, 3 and 4, that would be in cluster number 1. And centroid of cluster number centroid of cluster number, you can say that 0 is you can say that centroid of cluster number 0, which is 16, 36 and 25. This is the centroid of cluster 0, and this is the centroid of cluster 1. So 3 outputs you will get. Assign clusters for instances, centroid of cluster, in this case centroid of cluster 0 and centroid of cluster 1. So in this video you have learnt about basic concept using numerical k-means clustering, and I have also shown you Python code. Hope you have understood. Thank you for watching this video.